So guys, thanks for joining this Saturday morning, and we'll finish it very quickly today. So in the last class, if you remember, we were doing some solved examples on hypothesis testing using p-value method and critical value methods. So we had covered this initials of method, p-value method. What is p-value method? We had covered two-tail testing example using p-value method. Then same two-tailed testing example with critical value method. So I explained you in the last class also that p-value method is more common and more popular. So we have to concentrate more on that. So remaining two examples I have taken little differently, but I have taken them only on p-value method only. So the previous two examples, 1 and 2, were on two-tail, right tail, both tail, that it was a two-tail scope. So if confidence level is 5%, we have to split it 2.5 on the left of the bell curve and 2.5 on the 2.5% on the right of bell curve. So this time I am explaining you one example by left tail method, p-value method, left tail method, how left tail method works, and then one example with one more another. This we are assuming that Gaussian distribution, right? So in the next example 4, we'll be assuming T distribution less than 20. So suppose our number of samples are 30 or more. We take generally a standard normal distribution, right? And we take p-value using that. So this time we'll be using more than 30 examples only, but the nature of the tail will be left tail test. So in the interest of time, I'll jump into the problem. So we are doing left tail method, left tail test using p-value method, and our number of samples are more than 30, and we are using a standard normal distribution. Okay, so there is no change in doing the example which is by the method what we did in the last time. Method is same, but just only thing it is from two-tail test, it is a left tail test. So let us see how to deal with that. Let us assume that we are a company that manufacture light bulbs, manufacture bulbs, and we want to test whether our production process is yielding bulbs with the desired lifespan of 10,000 hours. So we want to test whether our bulbs are, all our bulbs that we are producing are having minimum lifespan of 1,000 hours. We conduct a hypothesis test using 50 light bulbs. So sample size is more than 50 light bulbs means sample size is more than 30. And a significance level of 0.05. 0.05 means it is significance level means 5%, right? 0.05 means 5%. So we need as usual, we first define our null hypothesis and test alternate hypothesis. So null hypothesis will be that the average lifespan of our bulb is 1,000 hours. Whatever is given that we want to test that our lifespan is 1,000 hours. So we'll assume that the average null hypothesis is generally assumption, vague assumption, right? So we are assuming that average lifespan of our light bulb is 1,000 hours. 1,000 hours. So lifespan equal to 1,000 hours. That is null hypothesis. Alternate hypothesis will be reverse. The average alternate hypothesis, the average lifespan of our light bulbs is less than 1,000 hours. We are not telling not equal to, because not equal to means it can be less than 1,000 or more than 1,000. So if it is 10,000 and more, it will mix into our null hypothesis. So we have to test the alternative hypothesis that the average lifespan, is less than 1,000 hours. Less than means it is a left tail test. Next, we collect a sample of 50 light bulbs and measure their lifespan in hours. We say that the mean lifespan is 985 hours. The sample mean is the sample we have taken of 50 bulbs. The sample lifespan is sample mean is 985 hours. So sample mean is 985 hours. Okay, and the sample standard deviation is the sample of 50, whatever we have taken, the standard deviation is 30. Now, next we calculate the test statistics. So, test statistic is nothing but your Z value. Test statistics is nothing but your Z value. So, Z value symbol is simple. X minus mu divided by S divided by square root of n. So, here n is very simple, your test size. So, here n will be equal to 50. S will be nothing but your sample mean. Mu will be your population mean. And X will be your sample mean. Okay. So sample mean and mu is the population mean, and S is yours. So whatever values we got. So like sample mean is 985. We saw here sample of population. Sample mean was 985 hours. So sample mean is 985 hours. 185 and population mean is 1000. So how we taken 1000? In the hypothesis, we have assumed, null hypothesis, we have assumed that all our bulb mean lifespan is 1000 or more. So that from that null hypothesis we are taking, we are assuming that our population mean is 1000 divided by 30. 30 is the standard deviation of, so 30 here we have calculated as the standard deviation of our sample. So that standard deviation we have put here. And then the sample is 50. So if we compute this, so T statistics is coming in negative. Negative means towards the left of mean here. If you imagine the bell curve, and from the peak line, right hand side is positive, left hand side is negative. So this is coming 2.89 minus 2.89 means we are our Z statistic is 2.89 deviation towards the left from mean. 2.89 standard deviations away to the left of the mean. Okay. So this is our null alternate hypothesis is one-tailed. Alternate hypothesis is one-tailed. Why one-tailed? Because we are assuming that the average lifespan of bulb is less than 1000 hours. Less than means it is on the left side. Less than means on the, if we put not equal to 1000 hours, means it can be either less or it can be either more. So it will be two-tailed test. If we put greater than 1000 hours, so that will be a right-tailed test. So right now we are assuming that it is less than 1000 hours. So it is a left-tailed test. So we are using a left-tailed test. Left-tailed test we are using, and using a standard normal deviation T table. Standard normal distribution T table or calculator. Calculator I had shown you last time. So I am not repeating it in the interest of time. Find the P value. So I'll show you the calculator because it is open with me. And remember this value minus 2.89. Minus 2.89. So we have calculator here. And this calculator link I have given in the example 1. Example 1, I have already given the calculator link to you. So already where it is open. It is open. Let me open it. So from this document only I can open it. So from this document I will open it. So this is example 1, and at the end of that we have p-value calculator. Okay. So p-value calculator I go and I just click on that. I get my p-value calculator. Stop verification. I'm getting a p-value calculator. Now here it is now we have to first select, see on the left hand side here. We have to select whether it is a two-tailed test, whether it is a two-tailed test or it's a left-hand test or it's a right-tailed test. So ours is a left-tailed test. Z score. So what value we have? So we have our Z value we have. So your Z score. So here we have to put our Z score. So Z score was minus 0.29. So means we are getting our p value as 0.001926. Means it is approximately it is 0.0012. Approximately if you round it off, it will be 0.002. So our value of p is 0.002. Okay. So now we straightway go to our example 3. and see what P value we are getting in that example. So see, so in that P value also, we are getting 0.002. Now, our confidence level is, significance level is 0.05. Significance level is 0.05. So significance, since our significance level is 0.05, and we are getting the P value as 0.002. So P value is less than significance level. So 0.002, which is P value, it is less than a significance level of 0.05. 0.002. No, it is 0.002 is less than 0.05. No? So it should be less than, it is less than P value, right? So no, it is greater than, yeah, greater than GREA. So significance level is 0.05. So significance level is greater than P value because significance level is 0.05 and P value is 0.002. So significance level is greater than P value means we are coming in the red zone. If you remember that curve, we are red zone. So if you are, then we have to conclude that if P value is less than significance level, P value is 0.002, which is less than 0.05, that means we conclude that there is a sufficient evidence to support the alternative hypothesis. Means we are rejecting the null hypothesis and we are supporting the null hypothesis because P value is less than significance level. If P value is less than significance level means we are in the red region. Red region means we reject the null hypothesis and we support the alternative hypothesis that the average lifespan of our light bulb is less than 1000 hours. So see, what was our alternate hypothesis? So we are supporting alternate hypothesis, right? So what was our alternate hypothesis? Alternate hypothesis was the average span of light bulb is less than 1000 hours. So our test failed. Actually, we wanted that average lifespan is 1000 hours or more. But our test showed that the average lifespan is really sample, whatever sample we have taken. Based on that data, we are showing that the average lifespan of our light bulb is less than 1000 hours. So this is left tail test. Okay, this is a left tail test. So in the interest of time, I will quickly jump to T test. So now this time T, now above our sample size was 50, which is more than 30. 30 is the magic number, you remember. If more than 30, we go for standard normal test. If less than 30, we go for T test. So this time our sample size is less than 30. Sample size is less than 30. And we are again using p-value method here. Okay, no difference. Only instead of Z statistic, p-value Z statistic, we are calculating T statistic. So this time we want to test whether we assume that a company that produces a certain type of smartphone battery, company manufactures a certain type of smartphone battery, and where we heard that competitor has released a new battery that lasts on the average longer than ours. Means a competitor has made some good battery which is lasting more than our battery, our new battery. We want to test whether this claim is true by using hypothesis testing. So claim is that competitor battery life is more than our battery life. So we want to test this claim with hypothesis testing. So let us see how to do that. So significance level means the magic number of significance level is always 5%. So we'll compare our p-value with this. If p-value is less than this, we'll reject the null hypothesis. If p-value is more than this, we fail to reject the null hypothesis, right? So p-value is less than means p-value is less than 0.05 means 5%. We reject the null hypothesis. And if p-value is more than 0.05, we fail to reject null hypothesis.
Yes.
Okay. So now significance level is always 0.05 generally. So sample size is 12 batteries. This time sample size is less. Maybe these batteries are very costly or something. So maybe less are manufactured. So they cannot give you a sample of 30. Generally, sample of 30 or more is better. But if if sample given to you is less than 30, then also you have to do your work. So you leave t-test. Sample is only 12, n equal to only 12. Significance level only 0.05. So now we have to find out p-value. So H null hypothesis is, see how it is. The average lifespan of our smartphone batteries is equal to or greater than competitor. Like company CEO always thinks good about his products. So CEO is claiming no, our battery is better than competitor. And researchers are telling our battery is inferior to competitor. That's what researchers are telling. But company CEO or business guys are telling no. Unless you prove me, I will assume that our batteries are better than competitor. So that generally vague statements or irresponsible statements are generally your null hypothesis. So that is our null hypothesis. Then what we want to do? Greater than in null means less than. In less than sign will be there in alternate hypothesis. So researcher, what researcher wants to prove? Researcher wants to prove that the average lifespan of our smartphone battery is less than competitor. That's what they want to prove. So that is alternate hypothesis. So this is, guys, this is left tail test or right tail test or it's a two tail test. It is less than sign is there. That means it's a left tail test, right tail test, or left tail test, right? Yeah. If it is not if sign is alternate hypothesis, if it is not equal to sign is there, then it can be less also, it can be more also. So it is two tail test. If less than is there, less sign is there in alternate hypothesis, that means this is a left tail test. If greater than sign is there in alternate hypothesis, that means it is a right tail test. So this time we are framing our null hypothesis that alternate average lifespan of our smartphone battery is less than competitor. So it is a left tail test. We collected sample of 12 batteries and measured their lifespan in hours. So we took 12 batteries and in the laboratory, our factory laboratory, we measured their lifespan with our equipment. We can say that the sample means the battery lifespan. The battery lifespan is 36, right? Average lifespan is 36. 12 batteries we have taken life and taken the average. The average is 36 and standard deviation is 4 hours. Now, since our sample size is less than 30, we do not know the population standard deviation. Okay, sample size is less than 30 and we do not know the population standard. The population standard deviation will never be known. So in our formula, we need population standard deviation. So what to do? Alternative hypothesis, we are, let us see what he has done. Then now, since the sample size is less than 30, we are using a t distribution here. T distribution instead of a normal distribution. We calculate the t statistic using formula x bar minus mu. Formula is same. Where x bar is your sample standard deviation. No, x bar is your sample mean, mu is population mean, s is your sample standard deviation, n is your population, n is your sample size. So let us see. Since x is a sample span and mu is the population mean under null hypothesis, like I have explained to you. What we do that? We just put in the formula. Mu we don't know because population mean is not known. So mu we don't know. Mu we don't know. Mu we don't know. And rest all things we know. The sample standard deviation is 4. We know the sample standard sample average is 36. So we put everything. So mu is not known. So how we are solving this problem? We don't know the population mean. So we assume it is equal to the competitor claimed 38 hours. So competitor is claiming competitor is claiming that competitor is in the null hypothesis. We have assumed that, na. So null hypothesis. Where is 38 here? Where is 38? So okay. So we have some other data point we have. Some other data point we have that competitor is claiming that his This data point I have not written above, but suppose one more data point is given that competitor is claiming that his battery lasts for 38 hours. So we take that as a population mean. So 36 minus 38. So 38 is nothing but your claim made by your competitor that his battery is lasting 38 hours. So 36 is your sample mean, your battery sample, and whatever mean you got. This is your sample deviation 4 and square root of 12. 12 is nothing but your sample size. So this is a left tail test. And if we use a calculator, see, so we got minus 1. See this Z t value we got minus 0.39, minus 1.39. We have to use the same table. I will take you to. I'll take you to that calculator. So now here, instead of so here there are three options are there: two tail test, left tail test, right tail test. So we'll use left tail test because we are using it. Now what you have? You don't have Z score now. You have T score now. So calculate T score. And what is degrees of freedom? So these degrees of freedom I have not explained to you. Degrees of freedom is sample size minus 1. So guys, how much is the sample size in this case? How much is the Jignesh bhai? How much is the sample size in this case? Amit bhai?
Hello.
How much? Yeah, Jignesh bhai, how much is the sample size?
So we need to do -1 for.
Yeah, but how much is the sample size? What is the number of? What is the number? What is the n equal to? Amit bhai, what is n equal to?
Sir,
Amit bhai?
yeah, sir.
How much is value of n? See, value of n is nothing but 12.
Yeah,
N is 12.
So
and I think I'm going a little faster, I think, right? Is it so?
No, sir. No,
So
sir.
the sample size is 12.
Yeah.
So we have to use n minus 1. N minus 1 means 12 minus 1, 11.
Yeah.
So that 11 we have to put there. 11 we have to put there. So degree of freedom means n minus 1. N is 12. So 11 if you put T, what is your T score? So T score is minus 1.39, right? So you put T score. The T score you put, how much P value you are getting? 0.096.
Yeah.
So 0.096, is it greater than our significance level of 0.05 or less than 0.05? It is greater than 0.05, right?
Yeah.
Yes.
So will you reject the null hypothesis or you fail to reject the null hypothesis?
Fail to reject.
You fail to reject the null hypothesis, right? So let us see what we have done. So we fail to reject null hypothesis because P value is greater than the significance level. Significance is almost fixed. Unless somebody tells you that use significant level of 0.02, 3 or 0.02. If no significance level is given, we'll assume that significance level, and in most cases, significance level will be 0.05. So it is fixed. Our whole problem is to calculate P value, either using t-test or using standard normal test. So this was a t-statistic. T-statistic value was minus 1.39. Formula is same. Baba. Formula is same. And now here only instead of mix you have to do. This sample claim we have taken 38, which is given by, which is a sample population, which is a competitor mean. So you got the P value now with the calculator. So P value is greater than significance level. So we fail to reject the null hypothesis. Fail to reject null hypothesis means we can. If we fail to reject null hypothesis means we don't have enough evidence to reject the null hypothesis. So what was null hypothesis? The average lifespan of smartphone batteries is equal to or greater than competitor. So whatever. So right now we are not able to prove it wrong. Null hypothesis, whatever null hypothesis was there, we are not able to prove it wrong. So we cannot accept the alternate hypothesis because there is no evidence. So we cannot say this all evidence is showing that you cannot reject null hypothesis. That doesn't mean that you have to accept null hypothesis. You cannot reject it. That's what it means. You cannot reject it. But you can, that doesn't mean you can. So what you have to do, it doesn't mean that you have to accept it. But you cannot reject it also. So what you have to do, next time you collect better sample, take a sample more than 12. You see, however, you may want to collect more data and conduct further tests to verify the result. So right now the result is you cannot reject the null hypothesis, but that doesn't mean that 100% it is more than competitors or 100% your null hypothesis true. It doesn't mean that. It means that you have to collect more data and conduct a couple of more tests. If in all tests you fail to reject null hypothesis, then you can accept it. Suppose you conduct 3 tests, and in all the tests you are unable to reject the null hypothesis. Then you have to accept. But based on one test, there can be some problem with your sample. So you cannot simply say that if I cannot reject the null hypothesis, that doesn't mean that I can accept the null hypothesis. Got it, guys? So now I think I finished, guys. So both were 2 left-tail tests. Both examples were left-tail tests. And one was based on Z statistic, which is a standard normal table. And other was T statistic. So what difference it will make? What difference it will make to you here, guys? The difference it will make to you here is only thing you have to either select Z score here. If sample is more than 30, you have to select Z score. If sample is less than 30, you have to select T score. And if you select T score, automatically it will ask for degrees of freedom. So degrees of freedom is nothing but n minus 1. How much is n here, guys? How much is n? 12. Right? N is your sample size. Sample size is 12. So 12 minus 1, 11 you have to put.
Yes.
And suppose you select Z means it will not ask you sample size. See, it is not asking. Because then it is more than 30. More than 30 is always good. So then put your sample size, then from T tables, it will give you the value. So that's what difference it makes. And left-tail test means, see, my significance level is 0.05. And suppose my left-tail test is there. So with what I will compare? My significance level is 0.05 and I have left-tail test. With what I will compare? My p-value will compare with what?
P-value compare with the significance.
How much is significance level?
0.05.
Suppose I am doing right-tail test. So it will compare with significance level. How much is significance level? 0.05 again, right?
Yeah.
But suppose it is a two-tail test. Two-tail test. Not equal to. Your alternate hypothesis containing not equal to sign. Then what will be the significance value with which you will compare p-value? Tell me. See, now it is a two-tail test. And you have the p-value. So you will compare with 0.05 or something else.
I think it's.
I told you already. Just a little bit pressurize your mind.
Yeah. Both sides. Yeah.
Both sides. See, both sides means, guys, you have to halve the significance level.
Yeah.
If significance level total is 25%, for left-tail test, you have to make it 2.5 on the left, 2.5 on the right.
Both sides.
Yeah, so p-value will be compared with 0.025, not 0.05. Got it, guys? So if it is less than 0.025 in two-tail test, you can reject the null hypothesis. Or I am telling ulta. If it is less than 0.025, you can. What does it mean? If p-value is less than significance, what does it mean?
Less than means we are rejecting null hypothesis.
Yeah. So it is confusing kind of, guys. So couple of, see now, these 4 examples are there with you. Right-tail test is exactly same as left-tail test. So significance level 5% means you have to compare with 0.05. And here right tail test means you have to select right tail test. Like that. And then here, based on your sample size, either you have to select Z score. So Z score you will select when your sample size is more than 30. And T score you will select when your sample size is less than 30. Got it, guys? So
Yes.
see, it is a difficult topic, guys. I assume you take it as a difficult topic. Okay. So you have to bit of read it and you have to practice it. Unless you